Hi everyone, welcome back. In today's video, we are going to look at the problems from LOS 2. In previous video, I have explained the LOS, and as you can see, I have put it on the top of the problems here. It was about calculation and interpretation of different approaches to return measurements. All right, let's start with the first problem set. It is about holding period return and means. Okay, let's read it. Sarah Khan CFA is analyzing the performance of several instruments. She considers individual securities and funds historical returns. Her tasks involve measuring returns over single and multiple periods and evaluating average performance. Okay, let's start with the first question. Sarah buys a stock at $48, receives a dividend of $1.20, and sells it at $52, sorry. The holding period return is closest to. Remember, holding period return was a single period return measurement, and it basically compares the differences between the purchase price, sales price, and also adds the income received during the holding period. And here we have our purchase price at $48 and income and sales price. So what we need to do, we subtract purchase price from the sales price and add income and divide it by the purchase price here. And the result is 10.8% and the closest one is here is 11%. So the answer is 11% to this question. Okay, next question. Sarah also evaluates a fund with monthly returns of 2%, 1%, minus 1%, 3%, 4%, and 0%. The arithmetic mean monthly return is closest to. Okay, again, remember the formula. We are going to sum all these returns here and divide it by the sum of the returns. And I have already written it here for you. And when we sum up the returns and divide it by the number of returns, which is 5, we end up with 1.6%. So the answer is B here. Another investment produced annual returns of 10%, minus 5%, and 12% over 3 years. The geometric mean return is closest to. Okay, now we are going to sum all of the individual returns by 1 and find their products, and then we're going to find the calculation and subtract 1 from that. And it's going to be 5.38%, and the answer is B here. Let's continue with problem set 2. It is about harmonic, trimmed, and winsorized means. Alex Lee CFA is analyzing datasets where equal dollar investing and outlier control are critical. He applies different mean calculations depending on the situation. The first question is, Alex invests an equal dollar amount each month in stock prices of $50, $40, $25, and $20. The harmonic mean price is closest to. Okay, remember one of the application of harmonic mean was cost averaging, where we invest equal dollar amounts in a stock consistently, and then we are asked to find the cost per share. This is exactly the case here, and the answer to this question is 29.63. By investing equal dollar amounts over 4 days at this stock at these prices, the cost per share is 29.63. Okay, next question. EPS forecast from 10 analysts are given here. Using a 10% trim mean, Alex forecast is, okay, let's find this. Remember trim mean, we drop highest and lowest data from the data set and then calculate mean from the remaining data sets. In this case, we have 10 data points here, and we are going to calculate trim mean using the 10% dropped values. So since there are 10 data points, 10% coincides to the first and the last data here. And we are going to drop 1.8 and 6 from the data, and then calculate mean for these remaining values here. Okay, here you can see the formula for that, and the remaining data, the number of remaining data points is 8. So the trend mean here is 2.25. The last question from this data set, this problem set. Using the same data set, Alex applies a 10% winsorized mean. Replace lowest and highest with nearest remaining values. Okay, now we don't drop any values from the data. Instead, we are going to replace the lowest 10 and highest 10% with the with the closest values. Here, the outliers here in this case, or lowest 10% and highest 10% are 6 and 1.8, and the closest values to them is 1.9 and 2.6. And when we replace them with these numbers and calculate the mean, the answer is again 2.25. Coincidentally, in this data in this question, the winsorized and true mean are the same, but that's not going to be the case always. We are continuing with the third problem set. Mario Lopez CFA reviews a client portfolio with quarterly returns and considers methods of handling outliers in return data. First question. The portfolio returns for 4 quarters are 3%, -1%, 2%, and 4%. And we are going to calculate annual HBR by using quarterly returns. And we already have a formula for that. We need to change this individual quarterly returns and find annual return. And you can see the calculation here. And the answer to this question is 8.17%, which is B here. Now the second question. For another investment, annual returns were 10%, -5%, and 20%. Now remember, these are annual returns, and we are going to calculate arithmetic and geometric mean from these returns. Arithmetic mean is quite simple, and you can see the answer here is 8.33%. And for geometric mean, now we are going to multiply them and find the root and subtract 1 and calculate geometric mean. And the answer to this question is here 7.84%. Therefore, it is A. Finally, Maria faces return data with extreme outliers. She wants to reduce their influence without discarding observations. Now, what is the most appropriate mean to use here? There are two key factors here. The first one being outliers. And remember, we can't use arithmetic mean when there are outliers in the dataset because it is heavily influenced with by the outliers. Secondly, she wants to keep the data as it is, or in this case, not discard the observations. And when we use trimmed mean, we actually drop values from the data, or in other words, we discard them. So therefore, the answer is not trimmed mean as well. Finally, winsorized mean does not drop the data from the dataset. It just replaces outliers with the closest values. Therefore, the answer to this question is winsorized mean. Thank you everyone for watching the video. I hope you enjoyed it. If you want more videos like this in the future, don't forget to like and subscribe.